So we're now at the summary for week 4. And in summary, we should look a little bit at dict, at zip, at function definitions, and probably also at arguments, command line arguments. So I've tried to find an example that summarizes all this, and let's run it. Let's see what happens. So the way you run it is you type Python and then the script, summary week 4, and then you pass an argument, and the argument is described here. You see that you could just pass no argument if the length is 1, or you could pass one argument that would be basic or one argument that would be ASCII. Okay, so I'll just pass no argument at first, and then what it does is that it takes the alphabet and permutes it. So here is the permutation, and then it just takes some input. So I'll type in, like, let's say some input, and then it swaps things around. So it will replace the S by B, and you see here that in the table S corresponds to B, or S is mapped to B, and O is mapped to K. Let's verify this. Yes, O is mapped to K. Okay, so it replaces every letter that appears in my input by some other letter as determined by the permutation. So that's the encoded version. And then it goes back to the plain text by inverting this operation. So this is the execution of one. If I enter some more complicated stuff, so it's not complicated so far, but if I introduce special symbols, then those special symbols will be lost, and instead it just gives question marks. So this is the encoded version, and the decoded version you see matches except for the special symbols here that are not swapped. If you want a more thorough substitution, you can ask for ASCII, and this, yes, so this is refused here because in the case of ASCII, I need 2 more arguments that are the lower index of the ASCII characters I want to use and the upper index. So let's say I use only the characters between the 40 and this 120th index, and you see all these characters that are now recognized and all the substitutions that are possible. So, and now I can start typing my input, and I should probably not go too far, and this is encoded in this way and decoded in this way, and you see that it matches the plain text. So maybe I should enter until 127 and type this sentence, and this sentence has the particularity of including all the letters from the alphabet, and I encode it in this way, you see, and then I can decode it back to the version just below, and the plain text was originally here. Okay, the point is I could also encode in this way some special characters, and you see that the explanation marks will be actually in this case encoded to question marks, which are decoded to 999. Okay, so there is a slight problem here. It's not really a problem with my program, it's just more of a problem about how I use it, and the reason is that I haven't allowed low enough characters to include the exclamation mark in the characters that will be allowed. So if you re-enter the same phrase, a quick fox, etc., and this is encoded to ampersand, 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 and then decoded correctly. Okay, so now that we get a feel for how the program works, let's see how it's done. So of course it's using command line arguments, so there is a name equals main test, and then it's looking at sys.argv and at the length, and it's doing basic tests, and you can see that it's only accepting more arguments when the type is ASCII. And basically, once this is all done, there is some set of symbols that is allowed, and the symbols are permuted using the symbols permutation function. And then it's taking my plain text as input, and it's encrypting that my plain text using the permutation, and then it's decrypting my encoded version using the same permutation, and it's passing an argument that it has to go in the other direction. So there is essentially two functions that we need to learn about, the symbols permutation function and the crypt function. So let's see at how the symbols permutation function works. So the symbols permutation takes the symbols as argument and imports the random module, turns the symbols into a list, shuffles that list, but this is a method with side effects. So it will change what temp actually is. Temp is changed in place. So it will return now another string. This is converting a list to a string here. And this string will be all the permuted characters. Okay, so this is the first function we need to see, and we see that it's oops, there's a mistake here because I'm returning this as a string, right? Here you see that it's given as a string. Okay, now the second function I need to tell you about is crypt. So crypt takes in the plain text, the shuffle of the symbols, and some direction, and by default the direction is in. So it will you see the documentation here. The plain text will be a string, and the shuffle will be a permutation of the string ABC all the way to XYZ, and so on. So, and actually, again, the documentation is not up to date, so I should change it. I'm sorry. So this is a string and a permutation of the variable symbols. Okay, and then I do a substitution and I generate a new dictionary from the shuffle and the direction. And the direction here at this point, this is a keyword and this is a variable. So you have to understand really what goes on here. If I specify a new direction, then this won't be in, this will be something else, but it will be passed as an argument to direction. And then I return here the string that is obtained by substituting for every character in the plain text using the substitution dictionary that I have generated before. And how is the substitution dictionary generated? Well, by this function generateDict, which takes a shuffle of the symbols and a direction. So if the direction is in, then it will create a dictionary that consists of all the key value pairs of one symbol, one shuffled symbol. And if the direction is not in, so presumably out, it will take a dictionary that consists of key value pairs, where this time we go the other way around. We start with a shuffled symbol and then a symbol. And we also add empty space to that dictionary because we don't want to change the empty space. We want to keep the empty spaces where they are. So this generates the dictionary. So here you have a brief overview of a program that uses basically everything we've seen this week. You just have to be careful with one thing, and that's quite conceptual actually. So why didn't I pass symbols here as an argument to shuffle, to generateDict, or even to crypt? I could have, I didn't, and it's up to you basically. But the interesting question at this stage is, why does this work? And the reason why it works has to do with scopes and frames. So I hope you can think about that and you can figure it out.